All right, the class is on record. Okay, so today we continue from where we stopped. We were able to handle yesterday. We did set difference. I think we stopped at universal sets. That was where we stopped yesterday. So to complete all we have from that course, we also proceeded to power set, and that's where we stopped yesterday, power set. So today, let us look at these joints. These joint sets. First, let me confirm. I hope the board is very clear.
Yeah, a little better.
Better, okay. All right. So we also pray that we have a good internet flow so that, so these joint sets, I'm going to be a little bit fast today. These joint sets are sets that have no elements in common. These joint sets are actually sets that have no elements in common. They don't have common elements. The elements in the different sets that are available, they are actually not, like I keep saying, no repetition. There are no repetitions. For example, if we have this set A, and set A are actually some days of the week. Like we have Monday, we have Tuesday, we have Wednesday.
Hello, sir.
And yes, please.
I don't know how I can reset the ball because it's kind of blurring a little bit.
If it's blurry, is it
it's
blurry
not like
for
yesterday.
everybody? That should be network. Is it blurry for? Is it okay now?
Still the same. Let other confirm. Yes.
Please, every other person confirm because I want to move fast. James, is the board blurry at your end?
For my end,
still blurry.
Okay.
Yes.
So if it's blurry, you need to shift a little bit from where you are because I have 1001 light around me now, so which will help us to get it perfect enough. So, and the internet is flowing steady. Friday, Cinderella, is it blurry at your end? Memunat, is it blurry at your end?
Yes, sir.
No, in my own end, it's okay.
Okay, it's okay. All right. So let's go. So if you are finding it, if you are finding issue with a blurry picture, just shift a little bit from your end, then you get a better view. So we have, as I said, that these joint sets are sets that have no elements. They have no elements in common. This is the first set, set A. Set A has these elements. The elements that it has is some days of the week, which is Monday, Tuesday, Wednesdays. I didn't say all of the days of the week. I said some. Monday, Tuesday, Wednesday, Thursday. And set B have the other days of the week, like Friday, Saturday, and Sunday, just like today. So these joint sets is how you look at the two sets, they are actually disjoint. Why? Because they don't have any element in common. We have here Monday, Tuesday, Wednesday, Thursday. We have Friday, Saturday, Sunday. So they don't have any common, like a sort of repetition. Yeah, somebody may ask, how do we denote disjoint sets? There is actually no particular symbol that is used to denote a disjoint set. So you could just say that I think some text denote it this way. Some text will denote it this way. And some other ones will say A intersection B is empty. It is empty. So you can actually represent a disjoint set in this format. Because if you look at A, the intersection of A and B, nothing is there. So there is no intersection between set A and set B because they don't have a kind of repeated elements among or members among the set. So this is how you can denote it this way or you denote it this way. So let's take another example. Another example, I call this 2, I call this 1. So if we have elements, we have set A, with the following elements 1, 3, 5, 7, and 9. And we also have another set B with these elements 2, 4, 6, 8, and 10. These are the elements in set A and set B. We can also go ahead to say the same thing, that A is a disjoint of B. So they are both disjoint sets because they don't have similar or they don't have elements in common. Look at the elements here. These are the elements. We have 1, 3, 5, 7, 9. Then we have 2, 4, 6, 8, 10. There are no elements that are repeated in any of the sets. So they are actually disjoint sets. So we can also put it the same way. A intersection B is empty. A intersection B is what? Empty. That's just it about what's it called? Disjoint set. But let me bring up this one in case you may come across a question. I'm taking this out. You may come across a question. You may come across a question like this with this sample, and you have sets. Let me call it set S. To have the elements 1, 3, 7, 8, and set T to have these elements 2, 4, 7, and 9. 2, 4, 7, and 9. So you are asked the question: Are these sets disjoint? If you look at it, we have elements in common. These are the elements in common. So they are actually not disjoint. They are actually not disjoint. Why? How do you represent this now? You say 7. 7 is a subset of S, and 7 also is a subset of what? T. What you are trying to say is that 7 is in S, set S, and 7 is also what? In set T. Did you get that? So they are not, S is not a disjoint of T. This is how you actually answer this kind of question. Did we all get that? Did you get that? That's a very simple one, very straight to the point. Did you all get that?
Sir, please, can you rewrite the last standard you just read? L is not the disjoint because I can't really see what is there. S is
The
not the
last line
what?
I just wrote.
Yes,
what
yes.
I wrote is
yes.
S is not a disjoint of
Okay.
T.
All right.
S is not a disjoint. All right. Okay. But I hope we all get it very clearly.
Yes, I
We all
do.
understand.
Me, I understand.
Yeah.
Okay. Memunat, you want to say something? Go ahead. All right. So I will assume that the silence is that we all got it. So I'm taking everything out. So the next is actually, I know we have touched a little on Venn diagrams. I know we have touched a little on Venn a little on Venn diagrams. We have touched a little on Venn diagrams, but I want to take out time today to elaborate on it, Venn diagrams, because I observed that even the little light I threw into while concerning Venn diagram, while we were taking union and intersection, most of us are still not very familiar with it. So what are Venn diagrams? Venn diagrams are graphical representation used to visually illustrate the relationship between sets. Venn diagrams, okay, let me write that out. Venn diagrams Venn diagrams are graphical representation used to visually illustrate the relationship between sets. So what it does actually is just to say this is, when you see the diagram, you should be able to, because you can see. So that's why the word visual is there. Because you can see, you should be able to interpret what you are seeing. That is what it means essentially. So, for example, we have something like this. So Venn diagrams are usually represented with circles. With circles. Venn diagrams are usually represented with circles. Now, this actually brings us to what? Types of Venn diagram. Types of Venn diagram. Well, that's not actually stated in our course material, but let me treat it so that we can help us. We have two main types, although we have about 4 to 5 types of Venn diagram, but let me focus on two. That is in line with what we are learning here. So to avoid confusion, you could go do extra research on that, though I may likely mention the other ones. But the two main types of Venn diagram we have the two sets. The first one, we have the two sets Venn diagram. The two set Venn diagram. The two set Venn diagram consists of two overlapping circles. Two set Venn diagram consists of two overlapping circles. Like I drew, these are overlaps. I've told you that Venn diagrams are represented using circles. Sorry, my circle is not perfect. Looking like a sphere. Looking like a sphere. The sphere is not a perfect circle. So looking like an egg as well. So don't mind the drawing. So we have C, D, F, we have A and B, and A, B here. So you see the capital letter A and the capital letter B are actually the sets. So A here is actually showing for the first circle. For this first circle here, it represents the set A. So this here means that the set A has 4 elements. Set A has 4 elements. You see this overlapping, this point of intersection. This point is called the intersection, where we have C and D. Let me try to color it. I think I did that initially. This part is called the intersection. The part I just colored now is called the intersection. That part is called intersection. But let me take away the coloring because I have something there initially. So we have C and D. So the way if you see a Venn diagram this way, yes, Susan.
Good afternoon, sir.
Good afternoon. Good evening. Welcome.
It's blurry. You're not seeing anything.
We or you. Is this blurry still for everybody? I like us to be responding so that we can meet up time. I want you to respond. If I ask, somebody can just lift up
I
and
don't
say,
know. I think it's next
Although,
on my
okay.
end.
so it's not like yesterday, but you can please see through.
All right, okay, let's all
If
move.
there's anything,
Now, let me tell you what to do if it's blurry. If it is blurry at your end, what you need to do, just log out and log in again, or simply change direction, position. It has to do with the network. It has to do with the network at your end. It has to do with the network at your end. Did you get that? So I hope that is better now. All right, so let us go on. Now with what we have here, we have two sets, set A and set B, and they have elements. So if you are given a pictorial or a graphical representation of this form, if you are given a graphical representation of this form and you are told to say A union B and A intersection B, you say, maybe they say what is A, B, what is A union B? And let's say C, what is the set A? And D, what is the set B? What is the content of the set B? Now, I want you all to give your attention properly. If you are given a pictorial representation of a Venn diagram, a two-set Venn diagram like this, and you are told to interpret it, you are told to interpret the Venn diagram. What the A union B is actually this point of overlapping, this point where they overlap. So whatever elements or members you find at this point of overlapping, that is actually the what? Intersection. So we should say that the intersection of A and B, A intersection B is what? Is CD. Then the union, we had said that union is the sum up of all elements in whatever numbers of sets. So now we have just two sets. We have two sets there. We have set A and we have set B. So the total number of elements we find in A and the total number of elements we find in B. So what you just need to do, you look at it now. So you have 1, 2, 3, 4, 5, 6. That includes the content, the remaining content in this particular circle, the content in the overlapping, and the content at this other side is actually your union. So your union is what? A, B, C, D, E, and then F. So the third question says, what are the elements? What are the elements? This one is just saying, what are the elements in set A? So the elements in set A includes what you are seeing in this part of the circle together with what you are seeing in the overlapping actually makes up the what? The set A. So you see that the circle is like this. The circle is like this. So in spite of the overlapping that you are seeing now, in spite of the overlapping, it is actually telling you that C and D is also a part of what? A. So the set A is actually what? A, B, C, and D. Did you get that? So now let us find B. Let us interpret set B. Just like I interpreted A, that's the same way you are going to interpret B. B is actually the entire circle like this, the entire circle like this. That is this element, the elements that you find here, together with the overlap, together with the intersection. So you have what? E, F, C, D. Did you get that? So those are the what? Those are the elements that we have in A and B. I hope we all got that. I hope we all got that. Is there anybody that's confused with what I've explained so far? You can quickly raise your hand so we can call your attention and address it right away. Okay, so let me assume the quietness is understanding. Let me assume the quietness is understanding. So I take this out. So we are still talking about types of Venn diagram. So the second type of Venn diagram is the three sets Venn diagram. Three set Venn diagram. The three set Venn diagram is it is three overlapping circles used to represent three sets. That is a three set Venn diagram. Three overlapping circles. So let me draw the circles now. Let me try to make the circle really perfect. This is the first circle. This is the second circle. And this is the third. This is the third circle. This is the third circle. So if you look at it very well, okay, let me call this set A, set B, and set C. Set A, set B, set C. The point of intersection of A, intersection B, intersection C.
Hello, sir.
Yes, please.
Please, I'm not seeing the board though. It's like the board is blurry. I cannot see.
It is your network. It is your network. So I guess you need to shift from where you
Okay,
are.
please, can you read out the three set Venn diagram that you just wrote, because I'm not seeing those letters.
All right, three set Venn diagram. What I said, it is three overlapping. It is three overlapping circles used to represent three sets. Three overlapping circles used to represent three sets. Yes. All right, so we have 1, 2, 3 circles, and they are representing three sets, set A, set B, and set C. So the intersection of A, B, and C is actually, if you look at it very well, this is not the intersection of A, B, and C. This is actually the intersection. This is the point. This point that I just shaded down. That is the point of intersection of A, B, and C. This point is the intersection between A and B. This point is the intersection between A and C. This one here. This point is the intersection between B and C. Did you get that? I want to take that again.
Yeah, repeat that again. Sorry.
The shaded part, you know, when you draw the circle, there is a point where the three sets intersect, and that is actually called A intersection B intersection C. So if you look at the circle very well, when you draw it, even when you draw by yourself as you are, wherever you are now, if you draw three circles and making them to meet, to overlap with each other, there's a point where the three circles actually intersect. If you look at it very well, this is the point where the shaded part now, where I just shaded. Okay, so let me take it out and let's look at it together again. All right, so if you look at it very well, you see this is the point where A, B, and C intersected. So this is the point of A intersection B intersection C. Now, if you look at this is the circle for A, this is the circle for C. So here is the intersection between what? So this is actually what? A intersection C. B and C, this is the point where they intersected. This is circle B and this is circle C. So if you look at it very well, this is the point where they actually intersected. So this is what B intersection C. Then this is circle A, this is circle B. If you look at it very well, this is the point where A and B intersected. So this is actually what? A intersection B. Did we all get that now?
Yes, I do. Yeah, I understand. Thank you.
All right. So how are people leaving the class? I hope there's no issue. All right. So James, can you see the board? Iroro, can you see my board very clearly?
I can see your board, but
I can see,
the
but
problem is you have to keep the camera a little bit away from the board. The camera is too close to the board. This is why it's blurring.
Is that better now? But I don't think that's the reason why it is blurry. Like Iroro, you are using two. Is it better now, James?
No. I prefer the first one.
Okay, yes. Someone's hand is up. Damilola. Damilola, go ahead.
I think maybe you should increase your handwriting a little bit. It's too tiny. Maybe that will give us a clearer picture of the letters.
Okay, all right, I will increase it. But that's the same handwriting I've been using since, but I will increase it.
But I don't know why it's okay. Thank you, sir.
All right, I will do that. I will increase it. I will increase it. Is it better now? Okay. All right. So what I was just saying essentially is that I was just trying to, okay, let me take out this. I guess we have gotten this part. I'm going to draw the circle again and make it large enough. I'm going to make it large. This is Can you see the three circles I've just drawn?
Yes, sir.
The three circles I just drew now.
Yes, sir.
So, and we have circles. This is A, this is B, and this is C. This is the point where A intersects with B and also intersects with C. This is the point where they all intersect, A, B, and C. If you look at the circle very well. Now for A, this is the circle A. B, this is the circle B. The way I drew it now. This is the point where A intersects with B. If you look at A and C, this is circle C. Just like we have circle A here. This is the point where A intersects with C. So this is A intersection C. This is circle B, this is circle C. This is the point between this circle and this circle. This is the point where they intersect, B and C. So we can say here B intersection C. Did you get that now, Damilola?
Yes, sir. Thank you. Yes, sir.
All right.
Thank you, sir.
Very well. Okay. All right. So we can now push ahead. Like we are saying that we have the three-set Venn diagram is actually used to represent three overlapping sets. Aside overlapping sets, it can also represent a disjoint. You know, I just finished talking about a disjoint set. This is how disjoint sets are represented. Disjoint sets do not overlap. Disjoint sets do not overlap. So this is the Venn diagram for a disjoint set. This is the Venn diagram for a disjoint set. Why is it this way? Because they have no intersection. Remember when I was talking about disjoint set, I said disjoint sets are sets that do not have common elements. They don't have similar elements. And we give example. So for example, if we have set A to have this element 2, 4, 6, and set B to have these elements 1, 3, and 5. Then set C to have these elements 7, 9, 11. If you look at the three elements, the three sets rather, if you look at the three sets very well, check the elements. There are no common elements around them. So this is how, if you are told to represent these sets in a Venn diagram, you represent it this way and you say they are disjoint sets. Did you get that? Did we all get that?
Yes, sir. But hello, sir.
Yes. Yes, I'm here. I can hear you.
But is it okay if we add the numbers inside this set, like this set
Very
A,
well.
add it into the circle of
Exactly.
A?
Yes. This is what James means. This is for A, this is for B, and this is for C. So this is 2, 4, and 6. 6. Then for set B, we have 1, 3, and 5. Then for C, 7, 9, and 11. And please always ensure to write it spaciously, like give space in between them. You don't need to go and write it like this. For example, now we have set B has 1, 3, and 5. Because there's no, you don't do comma within the circle now. So if you write it like this, what does that mean, James?
That's
James, can you
13.
tell us what? Okay, that is 13 and 5. So you see, you need to space them. You need to space them. You need to space them. You need to space them so that it will show that these are the elements. You don't put it in a way that it will look like the elements, because if you don't space it, maybe you are told to represent this in a Venn diagram and they are actually disjoints, whether they are disjoint or not disjoint, even if they are intersecting, sets, you must separate the elements. Don't put them close. Let it be shown that they are actually individual elements or members of that set. Don't bring them close. Please take note of that so you don't make a mistake. So it will not be assumed like when you are probably doing pen on paper, or when you are even filling, if you are doing, what's it called? Filling the gap. Yeah, if you're doing filling the gap, so don't go and put it very close. So making it look like 13 for that matter. So that is actually how to, this is type of sets. These are types of sets. So So if you know how to represent sets with Venn diagram, okay, Memunat, welcome back. Go ahead with your question. Yes, Memunat. Okay, Jacob.
All right, sir. Good evening, everyone. So I just want to ask, this pattern that one of our sisters just brought out now, is it acceptable? Can we come across? Can we just come across this in an exam, or if we come across? Sorry, can you hear me, sir? I said that the way you are arranging it now in Venn diagram, is it acceptable? That is we have two different way of arranging it. The one you using Venn diagram and the one you denote with both numbers and alphabet. So I'm trying to find, is it acceptable you denote this by using Venn diagram?
Yes, it depends on the question that comes first.
All right.
Do you understand? If the question says, if the question provides you with these elements now in these three sets, this is a set, this is set A, this is set B, and this is set C, and it tells you represent it in a Venn diagram.
Okay. Yeah. Thank you so much,
this way. Do you understand? So, what the person, yes, so what the person is trying, or the examiner is trying to ask you, is to know if you have an idea of how to represent a disjoint set. Did you get that now? So if I put this kind of question and say represent it in a Venn diagram, what I expect is that I should see it like this. So even if you don't make any statements, you have already given me a pictorial, because I have eyes and I can see. When I see that, oh yes, Mr. Jacob knows what he is doing and he has represented it the way I want it to. He has actually passed a message to me that this is a disjoint set, even if he doesn't write it in words. Did you get it now? So it's just like maybe when you are driving, if you are driving and you get to a particular point and you see a signpost that writes something like this. That is. Mr. Jacob, what does this mean?
Sure, I'm not a driver, but they're not allowed. That's what I mean. You mean not allowed?
No. Okay, all right. So, is there anybody that can tell me what it means?
Drivers in the house.
Yes, any good
driver in the
driver
house.
can
Not gonna talk about that. I want to learn today.
All right. So we are not in driving school, but what this means is that no U-turn. No U-turn. Do you get? So even if they don't write it there on the, usually if you see those signs, they will never write the interpretation. They will never write the interpretation. So they will not write there no U-turn. We are expected that once you see this symbol, you should know that don't try U-turn there. So that is why, like those of you in Lagos, those last mile people that can catch people anyhow, once they just see you, just make bam, they catch you. Because they expected that you should know this sign. So this sign is actually a language. This is a sign, it's called a sign language. So Venn diagram is actually a sign language. So Memunat's hand is still up. Memunat, can you speak now? Something is happening to Memunat's end. Memunat, go out and come in again. So maybe, I guess it's your network that's making you not to speak out. So let's hear from James. James, go ahead.
What I want to ask is, because I'm really lost. Not like what you are teaching. In what aspects are we going to use this mathematics as in this set of a thing in our field of studies?
Okay. I'm going to give you the VC's phone number. You call him and James. Okay. All right. It's called let me answer that question. It is called Mathematics for Management Science. Mathematics for Management Science. So if you look at your course material, it's written there. Mathematics for Management Science. Now, the essence of all this mathematics is just to improve your logical reasoning. Do you understand now? So what I am doing now, see, as I'm teaching you, when I come back to you, I ask you, do you understand? You say, yes, I understand. If you don't understand, you say, mostly you, James. James will always call my attention. Say, I don't understand this one. I am lost. You know, like some other people will say, I am lost here. Please, can you take it from here again? What I am actually doing while teaching you is that I am awakening your logical reasoning. So the essence of this course is to awaken your logical reasoning. So you can, when you are doing, I don't know, look, this mathematics for management science, some of you here are studying business administration. Some other persons are studying entrepreneurship, and I think some other persons are studying other related courses in the management science department. So the essence of the whole thing is to bring up, to awake how you reason, how you should be able to calculate this, how you should be able to do this. So that is the essence of, I think that's the best answer I can give you. Even the professor, even the VC will give you the same answer. I hope that is clear. So don't allow it give you stress. With the way I've been teaching it so far now, James, by now you're supposed to be a mathematician now with sets. Yeah, James. So don't be afraid of it. Is that why everybody is running away? Oh my God. All right, so let us go on. Let us go on. Let us go on. I don't want it to disrupt my so that's why. Okay, so the next thing we're looking at is operations of comparable sets. And take note that this course, Math 106, I hope it is marked as C. Is it marked as C amongst your courses? Is it marked as C among your courses?
No.
Is it A? I mean, is it E or C?
So I don't.
It's C.
It's C. It's C. It is a core course now. It's compulsory. It is not E. E is elective.
Okay, you mean the cure and the elective, that it is C, that is compulsory cure course.
Yes. Yes. Core is core, so you need it. So you cannot avoid it. So people that are running away. In fact, today in church, somebody came to meet me. There's some of you studying. Is there anybody studying business management amongst you here?
But is there any difference between business management and administration, if I may ask?
In noun, it is business management or business administration. Yes, biz admin. So if you are studying business admin, you are going to see STT 202.
That is statistics,
in your 200 level statistics.
Statistics.
So you cannot run away from it. Yes, you won't. Yes, exactly. So you won't run away from it. In fact, what some of you need to do is go and get a list of what you are going to be studying, all the courses you have. Maybe I will prepare. If you need it, come to me. Private chat me. I'm going to give you the list of all your courses from your 100 level to your 400 level. You need to know it. You need to begin to picture your mind. What am I going to, after this second semester 100 level, what am I facing next? That's how to prepare yourself as a very good student. What am I facing in my 200 level? First semester, second semester, what am I facing? Then in my 300 level, first semester, second semester, what am I facing? In my final year, what am I facing? You need to begin to project your mind towards your project now. All those things, see where's and you need to begin to gather your heart towards all these things. By now, this is the best time. If you don't plan now, you will fail. That is, if you fail to plan, you will plan to what? Fail. This is the best time to be. So like what you people are doing now, studying before the exam is very helpful. When you go in there, there's no way you will not crush mathematics. You will crush mathematics. Provided you are attending this class and you are giving your attention, you will definitely get it. I'm very certain. All right, so let us go ahead. So we can avoid mathematics. So operations of comparable sets. Operations of comparable sets. That's what we want to look at now. Operations of comparable sets. So comparable sets. Let me make my handwriting bigger. Comparable sets. Comparable sets are sets that can be compared on the basis of, this is actually there. On the basis of their cardinality. On the basis of their cardinality. That is what comparable. So the question now is what is cardinality? Let me explain that. Okay, we have this in we have operations of comparable sets. If you look at the course material, like I keep telling you, I think it's even easier for you people. If you go to science, look, most of the content on the course material is very confusing. They just write it. They expect you to go and do your own research, get it right. So comparable sets, this is actually operations of comparable sets is actually telling you what is a comparable set. So comparable sets are sets that can be compared on the basis of their cardinality. Cardinality there means members, numbers, elements, the element or members. So you know what elements are. Elements of a set. Elements are actually the members of a set. The content that makes up a what? A set. So you compare sets based on the numbers of elements or members that a set contains. That is what comparable set actually means. And I have said that cardinality of a set is the size of that set. So if I have set A, if I have set A, sorry that I always use A. A is very simple to use. So it's not like every set is represented with A. If I have set A, to have these elements 2, 4, 6, 8, 10, 12. The cardinality of set A is equal to 1, 2, 3, 4, 5, 6. 6. The cardinality of set A shows the number, or it says what are the number of elements found in set A. That is what cardinality means. So this cardinality will now help you to understand what comparable sets. So comparable sets are sets that can be compared with each other. Sets, see, not just one set, sets that can be compared with each other on the basis or based on their cardinality. So you can compare set A with set B. You can compare set A. I'm going to explain, I'm going to give an example. So if you grab this part very well, the next part we are entering will be very easy for every one of us. If you grab this part very well, the other part will be very easy for us. So this is cardinality. So I put out sets Q. Sets X. Sets T. So Q. So let me take Damilola, what is the cardinality of set T? What is the cardinality of T? Damilola. Is Damilola there? Okay, Cinderella, what's the cardinality of set T?
That is 3.
3. Awesome. Let me pick someone I've not always taken before. Who do I take again there? I don't want to take, it's okay, Otulubu. Sorry if I don't pronounce the name well. Otu, okay, let me just say Otu, O-T-U. Otu, what's the cardinality of set Q? Otu. Otu, what's the cardinality of set Q? Okay, let me take who do I take again now? All right, so I want to take Morenike. What's the cardinality of set Q?
Okay. Sorry, I was not in class yesterday, but I will try. I will use my brain. I think it's 3.
3 of set Q. Okay. 3. So you don't need to be in class yesterday. Now that you are here now. Thank you. You did very well, Morenike. So let's take my dear sister, Ever Bless James. What's the cardinality of set X?
It's 10.
Huh?
10. 10.
10. Okay, let's count. 1, 2, 3, 4, Good. So you see, that's very easy, very easy. But let us go to the part that we actually really need now. So cardinality is just the numbers of elements. So you just count it and give them the answer and move on. That's very simple. So have you seen it now that mathematics here is just to get you to reason logically, just to, oh, this is what it means, this is how it is. So you see now you can apply that in your business. Say, okay, how to know, okay, how many persons came to shop today. So if we say Emeka, John, Jacob, Efe, Monat, and James, they all were in shop today. These people came to do shopping. This one bought something, a good what? 2,000, 5,000, 15,000, 1,000, 6,000, 8,500. So the question now is, how many customers did we have at the shop today that visited my order, patronized my business, Mr. Jacob? How many customers?
The six
How many
customers.
clients did you attend to?
Six clients,
So
yeah.
that is just cardinality now. You get that is just cardinality. So the next question now says, how much sales did we make today? What that means is just add 2,000 to 5,000 to 15,000 to 1,000, 6,000 and 8,500. Then you get the what? The total. What is that? That is cardinality. So you see where you need this one to work with the other one. So it is not just, I already know how to add 1 plus 1. So it needs reasoning. You need to reason. So that is just the way it is. So I can bring up some other instances. So if you see that intersection, that Venn diagram I was doing, intersection of sets, you can okay. They said if in Jacob's business enterprises we have 200 trucks. Jacob Business Enterprises, he manages 200 trucks. If from the 200 trucks, if 25 trucks were delivered to Lokoja, 36 trucks delivered to Abuja, 50 trucks delivered to Sokoto, how many trucks did he have? Okay, how many trucks were sent out to the different states? How many? Then that's the first question. The second question now says, how many trucks were sent to Abuja and Sokoto? That is set. That is just simple set. The question that is put before you. So you that is doing business management or whatever your entrepreneurship you are doing, you can represent that information in a Venn diagram. So you say you have, let me just put it, still trying to help James to answer a question. Sokoto, Lokoja, Ikeja. Sokoto, 25 trucks sent to Sokoto. To Lokoja, 50 trucks. To this one, 20 trucks sent. What have you done now? You have represented it in a Venn diagram. So if the total number of trucks he has, there are 200 trucks, and they now ask you, how many trucks were sent to Sokoto and Lokoja? What that means is actually the intersection. So what are you going to do? It is to get what? The total of number of trucks of 25 plus 50. 25 plus what? 50 is what? 575. So 75 trucks. That is the what? Intersection. So now I ask you, how many trucks were sent were sent in total to all the states, to all the state capitals, Sokoto, Lokoja, and Ikeja. What you do is what? 25 plus 50 plus 20. You got 5. This is 7, 9, 95. So what you have here, this is the intersection of Sokoto, Lokoja, Ikeja. This is what? 95. This point is 95. So how many trucks did Jacob Enterprises send to Sokoto and Ikeja? This is the intersection. This place and this place. So it's what? It's 45. How many trucks did Jacob Enterprises send to Lagos and Ikeja? 20 plus. This is what? Is 70. So that is the what? Intersection. Are you getting that now? So if it's just that I was doing an assumption, if you actually add up the intersections, you should be able to get the total number of trucks that what's it called? Jacob Enterprises have. So that is 75 plus 45 plus 70. Forget about this by this thing. Now, if you want to get, if they ask you now, what are the total number of trucks? Maybe the question just gives you 25 trucks sent to Sokoto, 50 trucks sent to Lagos, 20 trucks sent to Ikeja. How many trucks do we have in total? So what you are just supposed to do is, Venn diagram will even help you to do the work very straight. You don't even need to give it. So you just draw the Venn diagram. You put here 25. So before you even take care of the intersection means you add this to this, you get this. You add this to this, you get this. You add this to this, you get this. So if I add 75, 45, and 70, what do I get? 75, 45, and 70. This is 0. This is 14, 15, 16, 17, 18, 19. So 19. So the total number of trucks that Jacob Enterprises owns is what? 190 what? Trucks. So James, are you now seeing the importance of mathematics in what you are doing now?
Yes, sir. Thank you, sir.
So that's the beauty of what we are doing now. It is not, mathematics is very simple. Mathematics is just follow the rules, follow the law. Once you follow the rules, you will get everything rightly. In fact, it's easier than all those other courses where you need to memorize things. This one is just, the principle says, when you go to the toilet, after using the toilet, you do what? You flush. That's the principle. So what you are expected to do, once you enter the toilet, once you finish pooing, you do what? You flush it. You walk away. That's the principle. It's a standard. But if you go in there, you finish pooing, you leave it there, and the next person goes in there and sees it and maybe tops his own or her own, it becomes a problem. It becomes a nuisance. So things will not go right. So that is just the beauty of sets. Thank you very much. I hope we are all excited to learn mathematics. It's very beautiful, very, very beautiful. It makes life very easy. So let us look at this very important part on comparability of sets. This very important part of comparability of sets. So if we have set A to have these elements, okay, let me start with 1, 2, 3, 4, and set B to have 2, 4, 6, and 8. Then we have set C. We have set C to have these elements 3, 4, 5, and 6. These elements. So now you are told now, so find A union B. Question number B, find A union C. Then question number C, find B union C. Then question number D, find B union B. What this means is that they are telling you to compare the elements in this particular set with the elements in the other set. So type of comparability of sets, we have union of comparable sets, then we have intersection of comparable sets. That is what we want to look at now. This will now lead us to another level of this thing. So this one, we have already treated all this before. This is just actually A union B. What is A union B there? A union B. A union B is the elements in A together with the elements in B, ignoring the intersection, ignoring the repetition. So if we see A, let's answer A now. A union B is actually what? If you look at it now, we start from 1. There is 2 here, there is 2 here. So we take one of it, bring 2, and then we take 3. We have 4 here, we have 4 here. So we just take 1, 4. Then we have 6. Then we have 8. That is actually the what? The union. That is A union B. So we have actually compared set A with set B. That's union comparability. That's what we have just done now. Then for B, the B parts, I'm going to wipe this. I'm just trying to make it very bold so that, we can all see it. Now, what is A union C? A union C is that you look at the elements in A together with the element in C. So let's look at it now. A, we have 1, 2, 3, 4. Then C, we have 3, 4, 5, 6. So we start from there. We have 1. Then we look at 2 goes next. What repeats here is 3 is here, 3 is here. So we take 1, 3. Then we look at the next one. We have 4 here. We have 4 here. So we take 1. So we have 4. Then next is what? 5 and what? And 6. That is actually A union C. That's actually A union C. So let me take out this part so that we can do the next one. B union. Let me take out this part. So let's do B union C. That's for C. B union C. What is actually B union C? B union C is the elements in A compared to the elements in B compared with the elements in what? C. So let us look at it now. What do we have there? We have 2. 2 is not repeated. We have 3 here. No, we just have 1 of it. So 4 and 4 here. We pick 1. We bring 4. Then how about here? What continues? What goes next? 5. And what goes next again? 6 is repeated. We take 1. Then what? The next is what? 8. So we have compared set B with set C. The last one is B union B. B union B. B union B is actually equal to what? B. So because B union of B, what that means is that you should actually write B twice. So B union B, so you have written, this is the first B, then you write another B. So it's 2, 4, 6, 8. That's another set. So we say B uniting with B. So B union B is actually equal to what? B. What is B? B is 2, 4, 6, 8. So which is equal to what? 2, 4, 6, and 8. Remember we said that elements do not repeat itself. Memunat, please. I'm seeing your hand up. Memunat. Okay, let's have the next person that the hands is up. Iroro, go ahead.
Can you hear me now?
Very well.
Okay, so my question is, with the A and B, the first one, where you have 1, 2, 3, 4. What happens if we have, for example, the first element, we have 12, 13, 4 up there. So how do you do it when it doesn't repeat each other?
You just add it up. You just add it up. So if we have, what you are saying is, if we have, for instance, 12 and 13 included in this set, what is
No,
A?
no. That's not what I'm asking. I'm asking about A, where you have 1, 2. If it's 12, not 1, 2. If you have to say 1, 2, 12, 13, yes, there.
12, 13, 14. Is
Yes.
this what you mean?
Yes, yes.
So A union B is going to be 2, 4, 6, 8, 12, 13, 14.
Okay,
Did you
I
get
got
that?
it. Thank you. Yes, I get it.
Yes.
Thank you.
So it's just everything here. So because of the repeating, so if nothing is repeating, just arrange them in order. If there's nothing repeating, just arrange them in order. Memunat, what's happening to your end now? Your hand is there, but we can't hear your voice. Okay, so maybe you just type your question, Type your question. Or maybe it's an old hand that is up. Iroro, are you raising your hand again?
No. I'm done with that. Thank you.
Okay, all right. So we are taking out the whole of that. So we are going to set identities. Set identities. Though that is not written in your course material as set identities, but it is actually shown there. But they didn't tell you that that's set identities. But I'm trying to let you know now that it is actually what we call set identities. It's actually what we call set identities. Just look at the board, you get what I'm saying. So set identities are equations that are true. Set identities are equations that are true or false. They are equations that are true or false. For example, if we have, set identity, the first set identity actually, there are rules, there are laws. So let me call it law number 1, law 1, or rule 1. Let me call it now. This is my own term now. The first one is actually called commutative law. Commutative laws. Commutative laws states that A union B is equal to B union A. It also states that this is the first one, the second one. The second one states that A intersection B is equal to B intersection A. Don't allow that confuse you. It's not an issue. It's very simple. Don't allow it. Don't forget about the law. Forget about when you see law now. You say, they want to now break my head. What it's actually saying is that if set A intersects with set B, it also means that set B can intersect with set A. Let me give an example. We have set A to be equal to, with these elements, 2, 3, 4, 5, 6, 7. These are the elements in A. Elements in B, we have 1, 5, 6, 9, and 11. So, to explain, to broaden our minds on this law, the commutative means that these are communing, they are talking with each other. So, what is A union B in this set now? A union B. James, what is A union B? James, what is A union B there?
Hello,
Huh?
hello. You said what? I couldn't get you.
I said, what is A union B from the two sets that have been given there on the board? This is set A.
Okay.
2, 3, 4, 5, 6, 7. Set B is 1, 5, 6, 9, 11. What is A union B?
Okay. A
Look at
union
this
B
set.
is
Yes.
1, 2, 3, 4,
Yes.
5,
Mm-hmm.
6, 7, 9, and 11.
Awesome. Awesome. Very good. So now what is so let me take why is Memonat's microphone not work? Memonat, can you hear me now? Can you take what is B union A? Memonat, if you can speak. Okay, let me take Ola. Okay, yes, let's just Ola. Ola is okay, eh? So Ola, what is B union A? What is B union A? Okay, Ola, you can speak. I see your hand up. Good evening, welcome.
So B union A is going to be 1. You put 1 first.
Yeah, it's 1 first, okay.
So followed by
Yes.
2. Yeah, 3, sir.
Okay.
4. 5. 6. You put 7.
Yes.
9, 11.
9 and 11. So have you seen now that the commutative law that is saying A union B is equal to B union A? So that's why I say don't allow when you just say law, is forget about the statement law. It doesn't make any sense. It is just saying that this is the same thing as this. That's what it means.
Hello,
So
sir.
yes, please.
Yeah, sorry to draw your attention to the question Madam Amino was trying to ask. You said that
Okay.
before you take the first rating off, you were saying that you repeat the C union A then. That's the first one. So I don't know whether you can still go back or not. That's a question, sir.
Okay, she was saying I should repeat B union A.
C union A. C union A.
C union A. Okay, concerning what we did before.
Yes, sir. Yes, sir. That's a question, sir.
I think I just wrote those things out of my what you do. I think the best thing is you go and play the video again. That's what will help because we've passed that part. It's no longer on the board. Most of all those things you see me write, I just bring them off my head. So I may not be able to bring that out again. But if I should give another example, how do we do that now? Okay, so let me say A, B, and C. Say 2, 4, 6, 8. And another one is 1, 2, 3, 4. And maybe 5, 6, 7, and 8. What was the question? I just formulated another one. What was the question?
Is it that to represent C union A? To represent C union A.
C union A. C union A is just everything here together with everything here. C union A means 2, 4, 6, 8. 2, 4, 5, 6, and 8. Do you understand? So C union A is actually what? You look at it here, we have 2, then you come there, we have 4, then you come, what else goes next is 5. What goes next is 6 is repeated, you write 6. Then what goes next is what? 8 is 7. What goes next is what? 8. 8 is repeated, you just put 8. Just the same thing with what you did now. So forget about the, we put 3 different sets. Even if I put 5 sets now and I tell you to do this one to this one to this one to that, what I'm just telling you, compare this one to this one. compare this to that. So even if I write 10 sets and I'm saying compare this set A to set B, or compare, I thought C element will come first before. Can I see that writing again?
Before A, she was saying that maybe C element will come first before A.
Now, let me tell you the thing. The thing is that I had said it before now that you arrange it in order. Do you understand? Arrange it in order. Yes. Whether C can come before A. Do you understand? Now C can come before A. So you can, if you say now 5, 6, if the options, if it is a question that is given to you, if the options are saying this, but the rule is that you're supposed to arrange it in ascending order. Did you get that? Did you get that?
To me, I understand all what you thought, since I really get
But
your point.
she cannot respond, but we understand.
Okay, all right. It's okay. Let's push on now very quickly, please. We have more things to do. So that is for, we have been able to take cumulative log. We've been able to take cumulative log. So one thing I want you to know, when you are answering the question, if it is an OBJ question, so if, like she is asking, if C union A shows the arrangement of the elements, bringing up C first before A, bringing up C before A, what it actually means, what it actually means is that the elements, like, no, we're talking about comparable sets, the elements that you find in A, you also found the same, you have also found the same element in set C. That is what it means. That's comparable set in respect to union. So in respect to intersection, there's another way we compare it. So the next is what? Associative laws. Associative laws. Please, let's give attention very well so that we can round up. We are really taking out of our time. It's just that I want to finish this unit so that I know the next we are going into unit 3. Going into unit 3. So you can see within a short time we may finish the course material. So associative law. Associative law actually states that A intersection B intersection C is equal to B intersection C. That's the first one. The second one says that A union B union C is equal to what? A union B union C. Then it has the third one. The third one says A intersection B in bracket intersection C is actually equal to A intersection B intersection C in brackets. That is associative laws. Those are associative laws. So let's take Iroro. Can you drop your hand down, or is it a new one? Okay, all right.
Yes, sir. There's something I wanted to ask you, sir. Are you hearing me? There's something I wanted to ask you. Sorry for disturbing. I wanted to ask you about the event diagram that we just treated before, where you have event diagram where you have 0 and you have another 0 inside. What do we call this?
We have 0 and another 0 inside.
Yes, we have 0 and another 0 inside. The outside 0 is carrying A, and the inside 0 is carrying B.
Maybe I don't. Okay. Circle. You should say circle. Is this what you mean?
No, the B will be inside A. The circle B will be inside A.
That is join.
It's not joining. It's inside. It's inside. Inside the 0. 0 inside 0.
Are you saying zero
Okay,
or
like
circle?
the two circle will be the circle B will be inside of circle B A. I think that's what he's trying
Yes,
to
that's
say.
what I'm saying. Circle B was inside circle A.
Okay. All right. So when you said zero, I was confused. Like this. Is that
Yes,
what you
yes,
mean?
yes. That's what I'm talking
Okay.
about. So the outside one is A, while the inside one is B.
B.
Yes,
Okay.
yes.
This means that what? A is not equal to what? B. That's what
Okay,
it
okay,
means.
okay. Good,
Uh,
good. Thank you.
did you get that? So it means that A is not equal to what? To B.
Thank you.
All
So
right.
that is to say that it's an empty what is it called?
Yes, actually. Okay, so let's go ahead with this. So round off because I have something to attend to very quickly. Then we have the third set. The third set is actually uh, the elements are 11, 12, 15, and then 19. These are the elements. So what we are told to do now is to look for A intersection B intersection C. In fact, already with Venn diagram that we did now that I represented, you can even get the solution to this. So, but when you see something like this, what you should do if you have three elements like this, I think there's something like that in the course material. They have three sets like this, rather, with their elements, and they say find A intersection B intersection C. What you are actually supposed to do is to what? First of all, find the intersection of A and B. First, find the intersection of A and B. Then the result, you now use it to what? To intersect C. Let me show you how you do that. So, what is the intersection of A and B here? A intersection B. Anybody? Mr. Jacob, what is A intersection B here?
We have three.
Intersection, oh, please take note. Intersection, not union.
Get
No intersection.
right. Hang on.
This is actually 11. Sorry, this is 11.
It is none.
Okay,
I think it's
Zero.
none. Empty set, none.
Empty.
Yes,
All right. It is
empty.
actually what?
Oh,
Empty.
are we?
Yes.
Empty, yes.
It's empty. There is nothing
Yes,
there.
empty.
So now A intersection B is actually what? Empty. A intersection B is empty because the elements 3, 4, 6, and the element in B is what? 7, 9, 11. So there is no repetition there. There are no common elements. Intersection are just common elements. So those are the things you need to grab. Iroro, is your hand still up? All right. So then now, A intersection B is what? Empty. What is B intersection C? Let us look at B and C. B and C now.
11.
11.
11.
11. So this is to show there is something missing here. This is okay. This was 13, not 11. I think it was my mistake. It was 13. That's 13 here. So B intersection C. What is B intersection C? Look at it very well.
Still zero.
Still
Empty
empty.
set.
Okay, zero, none. Empty.
B intersection C is also what? Empty. So this actually means that A intersection B intersection C is, if you look at B intersection C is empty. So the law states that if you intersect elements that do not, sorry, if you intersect sets that do not have the same elements, it is actually equal to the last two elements. Let me take that again. If you intersect sets that do not have common elements, set A, set B, and set C, none of them have common elements. You look at there, this is 3, 4, 6, this is 7, 9, 13, this is 11, 12, 14, 15, 19. No common element. Common in that case means no repeated element. So the law states that if you intersect three sets, the intersect of these three sets is actually equal to the intersect of the last two sets, which is what? B intersection C. So B intersection C is as well empty. So that means this also means A intersection B is equal to what? B intersection C. Did you see that? Do you understand? A intersection B is equal to B intersection C. What is A intersection B? Empty. What is B intersection C? Empty. So they are equal to what? Each other. Did you get that? It is also... Yes? Are you saying something? So that is for that. That is that aspect. So let us take some example. This is also applicable. A intersection B, A union B union C is equal to A union B union C. That is so. The union of it is the same thing the way you unite it this other way. The intersection is also the same thing with the way. So that is what the law states. Don't allow this plenty right to confuse you. What it actually means is that the elements of these three sets, when you combine them together, they should be equal to what? Each other, equal to each other. Like the first two equal to the what? To the last two. The first two equal to the last two. A intersection B is equal to what? B intersection C. Let us take this one. It's the same thing, that's what I said. So let us take this one. This is where we're going to round up now. So let's A, B, and C be sets. A is, let me change my ink as the last ink for the day. This is where we are stopping. So the assignment for this week is going to be 20 questions. So start early. 20 questions. So that's 8. 1, 2, 3, and 4. Set B. 2, 4, 6, 8. Set C. 3, 4, 5, 6. The question now is find A in brackets union B, then union C. Then the B part says find A union brackets B union C. This is how I'm going to explain this one. I may not even write. Let me just explain. What this means is that first take care of the first union and unite it with this other one. So this means is the union of A and B, which is 1, 2, 3, 4, 6, 8. That is A union B. You take care of it. After taking care of it, so okay, let us solve it now. So A union B is equal to what? What is A union B there? Let me take Memunat. Memunat, is your voice back now? Memunat, so sorry, please. Okay, Ola, let's have A union B. A union B.
Okay, sir. 1.
1.
Yes. Okay. 2.
Go ahead.
2.
Yes.
3.
Yes.
4.
Mm-hmm.
6 and 8.
Awesome. So A union B is what? 1, 3, 1, 2, 3, 4, 6, 8. So this is set C now. Set C. Set C is 3, 4, 5, 6. So what is A union B union C? You actually need to what? You are going to assume this A union B to be a particular set. Let me take that again now. This question is telling you now that you have found the solution for A union B, assume it to be a set. Let's call this set X. Let's call this X. So you are now saying that what? X union C. X union C. So what is X union C now? That is A union B union C. You look at it now. C is 3, 4, 5, and 6. So let us find the union. Let me take it here. So that means if we are calling here X now, which is this value that we have gotten now. So these are the elements. So we can now say what X union C or A union B union C is actually what this element compared with this what element C. So let us arrange it now. So can James arrange it for us? James, what is A union B union C now from the explanation I've given?
A union B union C. That is 1.
Yes. Okay, 1. Yes.
2, 3, 4.
Uh-huh.
5, 6, and 8.
Awesome. Very good. Very good. 1, 2, 3, 4, 5, and 6. 6 and 8. Very simple. That's just how it is. So then in this other part now, what you are actually supposed to do, keep A aside. Let A remain on its own. So take care of the brackets. Take care of this part first. B union C. So you now focus on this B union C. So what is B union C? Now B union C is actually 2, 3, 4, 5, 6, 8. 2, 3, 4, 5, 6, 8. So you now unite 2, 3, 4, 5, 6, 8 with A. So let us call B union C. Let's call it Y. So we have Y. We have Y to be what? 2, 3, 4. Abi?
Yes.
2. Where is it now? B union C. B union C. 2, 3, 4, 5, 6, 8. 2, 3, 4, 5, 6, 8. So, Roland, what is now A union B union C? So unite this with this. Yes, Roland.
1.
1, yes.
2.
2.
Hello, sir. Somebody shifted
3.
out your camera.
Okay. Sorry. I think it was my name. All right. 1, 2, yes.
3, 4.
Yeah.
5, 6, 8.
5, 6, 8. Awesome. So you see that from the set now, you can actually say, you can even form your law to now say that A union B union C is equal to what? A union B union C. Did you see that? That's how simple it is. So that is where Mr. Solomon is talking.
I'm kind of confused. Can you restate it again, please?
What we just did is not different from what we did in A. You are the one that answered A. So what you need to do is to look at, sorry that I've already wiped out set B. I've already wiped out set B. What we did in this A part, which you, James, answered, is the same thing we did in B. So set B had the elements. I can't really remember the elements again. So set B had the elements 2, 4, 6, and 8. 2, 4, 6, and 8. That was the element set B had. So it says A union bracket B union C. So you are told to what? Find the union between B and C. B is 2, 4, 6, 8. So when we found the union between B and C, what we had was Y here, which is 2, 3, 4, 5, 6, 8. So now the question is, what is A union B union C? So we called B union C Y. So we are now comparing A with what? Y. Comparing A with Y. This is Y. So we say now, find the union of A union B. So it's just like saying, what is the union of A to Y? What is A union Y? So you now look at these two elements, the element of these two sets. Then you do the same thing that you did in the other one. When you look at it, you just see the arrangement that it is 1. You start with the order 1, 2, 3, 4, 5, 6, and 8. So I said that A, when we found A, this is what we got now. 1, 2, 3, 4, 5, 6, 8. Then when we found the B part, we had a 1, 2, 3, 4, 5, 6, and 8. So I am now saying that this A is equal to what? B. That is A union B union C is equal to what? A union B union C. They are the same thing. Did you get that, James?
Yes, sir. But how come that this Y is having 2, 3, 4, 5, 6, and 8 instead of from 1?
Okay, let me bring it up again. Yeah, I'm telling to you,
Union C.
See, look at B now. See B. These are the elements in B: 2, 4, 6, and 8. These are the elements in B. So you check it now. Check it now. B union C. So James, what is B union C? B union C. Check it now. Look at it. What is B union C? James, I'm waiting for you. What is B union C?
Okay, it's 2, 4. Sorry, 2, 3, 4, 5, and 6.
2, 3, 4, 5, 6.
2, 3,
2, 3,
4,
4,
5,
5,
6,
6,
8.
and 8. 2, 3, 4, 5, 6, 8. Felicia, I'm going to call you. I'm almost done. I'll call you. I promise. 2, 3, 4, 5, 6, and 8. Those are the what? Elements. So you see where we got to. You just because I wipe it out. That's why you were a little bit confused. Yes, Ola wanted to ask a question.
Okay, sir. The question I wanted to ask is that if they ask us to make use of the curly bracket for the 3 sets, that's A, B, C, A, B, and C. So how are we going to represent him in the curly bracket? No, sorry, in a Venn diagram. Sorry, Venn diagram. Yes.
Okay, Venn diagram. You can still represent it in Venn diagram. So let me draw the Venn diagram now. So if you are asked to represent this in a Venn diagram, this is set A, this is set B, and this is set C. So you draw 3 circles, 2, 3. So let's call this A, B, and C. So what are the elements in what? A? 1, 2, 3, 4. So then you look at B, 2, 4, 6, 8. So try to look for, take care of, and then you look at C, 3, 4, 5, 6. So check first if there is any intersection between A, B, and C. Are there common elements? The one that is here, also here, and also here. Are there common elements? What are the common elements? 1, 2, 3. That is 4. 4 here, 4 here, 4 here. These are common elements. So Remember here is the intersection, so you put 4 here. So that is the first thing you need to take care of. Look at the common element. Find the intersection of the 3 sets first. So you now go to the next one now. So you now look at the first set and the second set. What are the intersections between the first set and the second set? So you look at set A and set B, the elements here. So 2 here, we have 2 here, we have 4 here, we have 4 here. So remember 4 is already here. So we are looking at the intersection between A and B. So just the intersection between A and B is just 2 and 2 there. So you put 2 here. So you now go to what? You go to the intersection between A and C. A, C, which is this point. So you look at A and C. What are the common elements in between A and C? Is what? 3 here and 3 here. 4 here and 4 here. Remember, 4 is already at the center point. So you don't even consider the 4 again. You leave the 4 where it is. So you take 3 and 3. Which other element repeating? None. So you put what? 3 here. Then you now come to the next one, B and C. This is this part now that is left now. B and C. You look at the elements that are there. What are the ones that are there? So we have 4 and 4. Remember, 4 is already here. So you don't bring it here again. So what are the elements that are repeated here? 6 and 6.
5.
It's just 6. So you put a what? 6. No, 5 is not this. We are looking at B and C now. So no, it's not 5, it's what? 6. So you put 6 here. So you've taken care of the intersection first. Now that you've taken care of the intersections, you now look at what is left. So already concerning A, you have 2, 3, 4. Because this whole circle means that you have 2, 3, and 4 amongst the elements. So you come to A. So already 2, 3, 4 is there. So what is left is what? 1. You now write 1 here. Then you now go to B. So B again has what? 2, 4, 6, which is this circle like this. 2, 4, 6. That is the circle. So you now look at B. What is remaining? So 2, 4, 6. What is remaining? 8. So this is 8 that is left here. So you come back to C. This is the circle C. The circle C has what? 3 enclosed, 4 enclosed, and 6 enclosed, collapsing together. So you have what? 3, 4, and then 6. So what is remaining? 5. So this is it, 5. Did you see that, Ola? That was a very beautiful form. Very beautiful. I see it's very simple now. So it's just how to take care of Venn diagram is pay attention to details. Look at it very well. If you don't look at it very well, you may mix it up. Sometimes some people will go and repeat the things that are there. Maybe they now write 4 here again and write 2 here again. No, you just take care of the things that are already. So you first of all, how to be able to get it right is take care of the intersection first. When you finish taking care of the intersection, then you can now come back to what? To the union, to the unions. So which are the remaining elements in the various sets. Thank you so much for your time today. I hope the class was a blessing to every one of us. Thank you. And see you next week.
Thank you.
Thank you very much.
Roland.
James, is your hand clear?
Yes, it's concerning my assignment, so you still haven't marked it.
Okay, I'll mark it. No problem. Thank you. All right, bye-bye.